continuation of the H.323 standard that we were talking about for the call signaling, and we will be talking about the various issues of H.323 because not all the issues we could discuss in the last class. So, essentially what we are going to do is that amongst all these issues, we should take up the control or rather call control, okay, and enhancements, because there are certain limitations that exists in the H.323 version 1, and we would like to see that how those limitations are overcome in the subsequent versions, and then only the H.323, I mean after avoiding those limitations, H.323 could be made at par with the PSTN telephones in terms of popularity. So, now regarding the call control, actually I mean before we go into that, just a quick look at the aspects which we had seen in the last class. Okay. So, towards the end of the class we were discussing two aspects. One is the protocol relationship, where you can see that essentially we try to separate the data and the signaling aspects. The signaling aspects are very important, I mean as far as its sanctity is concerned. Okay. It has to be a very reliable communication. So, Q.931 which addresses the signaling, H.245 which addresses the capability negotiation, T.120 that takes care of the data integration. Okay. All these things have to be sent through the TCP IP, whereas the bit stream which are generated from the codecs, the audio and the video codecs, they have to be transmitted over the RTP UDP IP protocol channel. And we had essentially identified 7 phases of the H.323's call, okay, starting from the call admission up to the call disengage. Okay. And this is the part where the actual message transfer is going on, means when the parties are actually in conversation is only this part. So, there are certain things prior, the signalings that is prior, and there are signalings that have to close down. So, these are taken care by the different parts of the protocol, okay, the RAS, the Q.931, all these things we mentioned. Now, it appears that the protocol could be quite I mean that it would involve some amount of time to go through this 7 phases. So, the protocol would make the process slower, but there are some shortcuts which are available, one of which I was trying to mention in the last lecture is that there is also a fast connect possibility where the call setup and the capability negotiation, these two could be integrated. In fact, capability negotiation part may be dispensed with in a small scale version of the H.323 system. And call admission, well, call admission's basic purpose is that there are several things that goes with the call admission, okay, that it is another level of protocol that is being maintained. And in fact, as I was mentioning that in the beginning this call admission was not there, so that the two endpoints could communicate, okay, without going through the call admission process, but really speaking the involvement of the gatekeepers, okay, makes that mandatory to have a RAS protocol for the call admission, okay, so that the call admissibility and its status monitoring, that could be done by the gatekeeper. Okay. Now, going by that, actually there are two basic models that can be thought of for the call control, okay, two fundamental call control models. One is what we are calling as the direct call model. In the case of direct call model, we will take the endpoints. Okay, let us say that this is terminal equipment number 1, okay, and this is the terminal equipment number 2, and these two terminal equipments, they want to have a communication, right. Now, here there will be obviously as far as the data part is concerned, okay, the RTP would be the protocol that would be followed in order to exchange the voice packets between TE1 and TE2, but before that some signaling is really required, okay, signaling and negotiations. Now, in the direct call model, the signaling and the negotiations are done between the TE1 and TE2 without the involvement of the GK, the gatekeeper. So, what are this, like the Q.931, okay, which is the signaling protocol that is what we were discussing in the last class. So, Q.931 could be used directly over the communication channel that would be set up between the TE1 and the TE2, and the H.245, okay, or rather to say, I mean, it is a direct TE1 to TE2 or TE2 to TE1 back, okay. Those communication would take place, and this would go through the H.245. Actually, this is the capability negotiation. But mind you, we have not shown any RAS. Now, RAS, if the RAS is dispensed with, in that case we do not have any problem. In fact, the direct call model can work without the involvement of RAS, or if you want to keep an RAS, actually in that case, if RAS is needed, in that case the presence of GK is necessary, because RAS is not something which you can have directly between TE1 and TE2. The RAS has to go through the gatekeeper. So, here if we have a gatekeeper cloud, okay, then we can have the gatekeeper to TE1 communication through the RAS protocol, and likewise between TE2 and RAS, okay, between TE2 and the GK cloud, it could be through the RAS. So, this is the direct call model, okay, and why we put it as dotted is that this block is an optional block, okay. We may dispense with this, okay, if so needed. In fact, that used to be the case, okay, in the initial PC centric proprietary VoIP applications. There was no concept of gatekeeper that was introduced, but when people planned for having a commercialization and exercising control of the GK, okay, there this RAS is necessary. But in this case, see that although it is only the RAS, but the signaling still takes place between the TE1 and TE2 directly without the involvement of the GK cloud, at least as far as the Q.931 and H.245 are concerned. There is a second alternative model which we call as the gatekeeper routed call model. And in this model, the entire signaling has to go through the GK cloud. So, we have the TE1 and the TE2. Now, TE1 and TE2 will only have the RTP between them, but all the rest of the signals, okay, has to pass through the GK. So, if we have the GK cloud here, then essentially any communication with GK has to start with the RAS, then the Q dot 931 and the H dot 245. Okay. Ultimately, it is endpoint to endpoint, but has to go through the GK cloud. Okay. So, likewise, even between TE2 and GK cloud, okay, it is RAS. Why is it called as GK cloud? Anybody can just throw some light on that? GK cloud, because actually what happens is that typically it is an interconnection of several WANs that would exist. Okay, we had shown in the last example, we had shown only 2 LANs, but it may go through multiple WANs. Okay. And in that case, there will be involvement of several GKs, because every LAN, I mean, whenever you are connecting from one LAN segment to the other, every LAN is going to have the gatekeeper. So, it is gatekeeper to gatekeeper, and again there may be involvement of more than 2 gatekeepers also. So, in effect it is a gatekeeper cloud. So, the gatekeeper to which TE1 is connected and the gatekeeper to which TE2 is connected is not the same, but we are showing the block as a GK cloud. Okay. And RAS, we have to have the Q dot 931 and this is the H dot 245. So, this will be the gatekeeper routed control model. The advantage that we get in this process is that in this case the gatekeeper has the control, okay, in the sense that since all the signaling is taken care by the gatekeeper and it is with the knowledge of the gatekeeper. Okay. So, that is why they call monitoring, okay, and call billing, okay, everything can be done because everything is under the GK. And not only that, one aspect which I did not explicitly mention in the last class is about the security, okay, because although again not in the version 1 of H.323, but in subsequent versions it was felt that definitely the security is very important, and especially when the call signaling takes place, okay, things like the authentication, the data integrity, okay, everything must be taken into consideration, and that is why there is also a standard, okay, that has been developed by the ITUT for the security or for a secured communication of all these signalings, because this is very important, because this is where, I mean, if you have any intrusion, okay, you can I mean that can lead to lot of unauthorized communication or could lead to the data corruptions and all such things. I mean any impersonation, everything can happen. Okay. Now, before we go into the security aspects, okay, a look at the call setup model that is going to be followed. So, we know now that one simplest model is without the gatekeeper, okay, where the RAS is not needed, even the gatekeeper also will not be needed at all, and there essentially everything is, the signaling is also between the TE1 and TE2. Okay. So, in that simplest model we can have the have an overview of the protocol or the signaling that has to take place. So, if we have TE1 over here and we have TE2 over here, okay, in order to show their protocol timings, okay, it is customarily shown like this, that whatever is at the TE1 end, for that we draw a vertical line, whatever is at the TE2 end we draw a vertical line below TE2, and this will be the time axis. So, this is the increasing direction of time, okay, so that whatever TE1 initiates at a particular time would be shown over here, and if the TE2 receives that signal instantly without any timing delay, then it will be a perfectly horizontal line. Okay. But if TE2 has got some delay, means if the perfect horizontal line ends over here, but actually there is a delay in the communication between the channels, supposing a delay of this much is there, in that case the line that you are going to draw should be an inclined line. Okay. The line can never have an inclination like this, because you cannot initiate something and then ahead of that it is received in the destination terminal. That is not possible. But so this is what we will be having for the setup. Okay. So this signal is for the setup, okay, that T1 wants to set up a call. Okay. So it is like you can say the dialing. So let us I mean look at it from the what you say, I mean from the PSTN considerations itself, that how it takes this. You want to communicate. So naturally what you want to do is to dial the number. So the setup, I mean there is no involvement of any gatekeeper. So the setup signal, okay, that would arrive over here, and if the path is completed, okay, if this T2 telephone is active, in that case it sends the call proceedings. So there is a call proceedings, so which means that it is an acknowledgement to the setup, okay, but actually the T2 may take some time, okay, although a direct involvement of T1 and T2 would make the ringing almost immediately, but let us say that in time the ringing is starting from here. So this is where the T2 starts ringing, okay, and the very fact that T2 is ringing, okay, would be also received in TE1. Okay. So this is called an alert, because with this signal TE1 gets prepared that now anytime T2 can lift the telephone, because you have, I mean T1 is the source, T1 initiates the call. So T1 has already lifted the handset, and T1 through this alert is actually listening to the ringing tone that is going on in the other end. T2's ringing tone T1's user is finding. So now T1's user is getting alerted that anytime when T2 user, okay, lifts his or her handset, then the call is going to commence. So only after that, only when the receiver at the T2 is lifted, okay, then the actual connect will be there. So with that there is a connect signal. So this is the simplest kind of a signaling protocol that would go on from the setup up to the connect. Okay. This looks pretty simple, because this is a direct connection. So this is what we are showing as the call setup with no gatekeeper. But when gatekeeper is involved, okay, the call setup procedure will undergo some change. Why? Because there will be the gatekeeper which is interposed in between. So there will not be any direct signaling that would go from T1 to T2, rather everything should go through the gatekeeper. So let us see that how the involvement of gatekeeper changes. We will show for one gatekeeper, but when more than one gatekeepers are involved, it is just a simple extension of what we are talking of. Okay. Now here let us say again we have a terminal equipment here, and we have another terminal equipment over here, and then we have a gatekeeper. We have a gatekeeper. Now the terminal equipment actually in this case, if it is between two LANs, okay, in that case one can have the gateways. Okay. So instead of the terminal equipments, we can also have gateways over here. So this is gateway on this side, this is another gateway, and the terminal equipment number 1 may be connected to this gateway, okay, and terminal equipment number 2 may be connected to another gateway. Okay. And then we could have the gatekeeper or the gatekeeper cloud coming in between. So, there we have the RAS, okay, and all the signaling protocols, okay, which would be over here. So, this is through the gatekeeper, okay, whereas the RTP would go through the gateway. Anyway, I mean that is not very that is not what we are trying to emphasize upon here, but let us see the kind of the signals that would be required. So, we start with the gateways, okay, and this is the GK, the gatekeeper. So, gatekeeper timings also would be shown by this vertical line. So, this vertical line corresponds to GK and these two vertical lines correspond to the gateway at this end and the other. And again, let us assume that it is the terminal 1 that wants to initiate a call. So, what now the terminal equipment 1 or this gateway has to do is that before the setup it has to ask for an admission request, okay, because there is a gatekeeper that is involved. So, RAS protocols are coming into place, and because of RAS protocol you need to have the admission request. The short form of admission request is ARQ. So, I am writing this as the ARQ. So, ARQ has to go from the gateway to the gatekeeper. Okay. So, this is the ARQ or the admission request. Now, protocol wise, I mean it is defined in the RAS protocol that ARQ has to be acknowledged, okay, if the admission is granted. Okay. So, there should be a signal which we call as the ACF or a admission confirmation. Okay. So, the admission confirmation has to come. Okay. In fact, it could be ARJ also, the admission reject. Okay. If the admission is not there, then it may also send an admission reject signal, but let us say that admission is confirmed. So, this is ACF which goes back from the gatekeeper to the gateway. So, now it is only after the admission that the gateway should initiate the setup. Now, GK has already accepted this TE1, GK has already registered. So, there is no problem in passing on this setup information, okay, to the destination GW, in turn to the destination terminal. So, we can show it almost instantly, but with a minor cosmetic delay. Okay, we can show that the setup signal goes from the gatekeeper to the gateway. So, this is not a direct connection, this is through the gatekeeper. I mean this gateway tells the gatekeeper, gatekeeper tells the next or the destination gateway. Okay. And in between this much of delay whatever is there, this is the delay by the gatekeeper. Okay. Maybe the gatekeeper software will have little bit of delay, okay, which may be negligible kind of a delay, but setup typically this is where the setup signal will reach over here. So, now when the loop close is detected, then the setup would be responded by call proceed. Okay. So, this is where we will be having the call proceed as before. Now, what happens is that you should expect that the alerting should be there, but mind you that gatekeeper although has sent the setup signal, gatekeeper has not yet admitted this terminal equipment or this gateway. So, the admission would be necessary now. So, what now, I mean when it sees that there is a call that is going to materialize, this gateway has to seek the permission of the gatekeeper. So, with the setup, see this is with the loop closer this will take place. So, no problem, but the gateway has to send an ARQ. Okay. the gateway has to send an admission request to the gatekeeper, and in response to that there will be an admission confirmation. Now, this gateway, the destination is also registered. Now, the source is registered, destination is also registered. So, now the alerting or the ringing takes place. So, alerting will be done first to the GK, the GK passes on this alerting to the source gateway. Okay. So, this is alerting, and now when this gateway or this T2 okay, is commencing the actual conversation or goes off hook and starts the communication, then this connect which is there, okay, the connect after so the connect will be routed through the gateway okay, to the source. So, this is where the connect will be there. So, this is with the involvement of one gateway one gatekeeper. So, what you can see in this case is that basically the setup, call proceed, alerting, connect, they remain almost the same, but there is an extra procedure which comes in, and that is this ARQ-ACF kind of handshaking, which is needed both for the source end as well as for the destination end. So, now this is the call setup with gatekeeper routed call signaling. So, call setup with gatekeeper routing. So, this is the second model that we were talking of. Of course, we are showing only the signaling part, but mind you again, I mean gateway to gateway communication, that would take place directly over the RTP protocol. Okay. For that the GK is not coming into the picture. GK is only for the admissibility and signaling. Now, also it is quite appropriate at this stage to talk about the security issues in H.323. Okay. In fact, H.323 has got a subset specifications okay, which is referred to as the H.235, which is the security protocol. Again, H.235 is the security protocol that is defined by the ITU. Okay. In fact, you will find, I mean from the name itself you will be able to make out that who are owning these standards, okay, because many a times the standards are or the protocols, they end with something P, TCP, IP, RTP, UDP, all these things are by the IETF, Internet Engineering Task Forces. Okay. Whereas all these standards like G.729, G.728, H.261, H.263, 264 or yesterday what we learned H.323 or the protocols like the H.320, 324, that is for the video conferencing. Okay. Everything is by the ITU. So, and there are sometimes I mean corresponding versions of protocols, I mean almost I mean quite identical version of protocols where the name given to the by the IETF is different from that of the name that is given by the ITU. Anyway, so H.323 includes a separate security protocol subset, and that subset is called as H.235. Okay. And this includes this H.235 security protocol includes 4 essential aspects. The first is what is called as the authentication. So, it is the user authentication that has to be done. So, essentially it is endpoint authentication. So, the T1 and T2, that has to be authenticated, that it is really registered to the network. Okay. They are valid users of the network, they are paying for it. Okay. Or I mean, if it is a commercial net, then they are paying for it, or otherwise if it is a network that is there in some classified domain, like say for example in defense or somewhere, then also the validity should be there, that it is genuinely known user or approved users who are working. And then the second security aspect is the integrity. Okay. So, whatever data we send from the source to the destination, okay, that has to be really validated. So, there should be a data validation, okay, because if you happen to be an intruder, okay, and you corrupt the data, okay, there should be mechanism of detecting this. So, data validation within a packet. Okay. So, there should be some checks which should ensure that. Okay. The third aspect is the what is called as the privacy. Okay. So, that one cannot really I mean look at the contents in an unauthorized way, like for any espionage or something, that you would like to steal or you would like to snoop into others private information. You want to know the credit card information when it is being transferred from one terminal to the other. So, these are some of the things that should be prevented with the encryption and decryption mechanism. Now, in fact, I mean it is there in the internet protocol, okay, and this protection should also be there in the VoIP, because VoIP is also by no means a, I mean has to be a secured communication, because whatever you are speaking, I mean why should your privacy be affected? Okay. So, encryption and decryption mechanism should be there. Okay. And then the fourth aspect is prevention against what is called as the non-repudiation. So, non-repudiation means that someone falsely denying that they participated in a conference. So, it is false denial of participation. In fact, this could be there in situations like, say for example, there is some inquiry that whether a group of people, they had a conference and then they plotted something, okay, plotted something mischievous, okay. And then if it is detected, then it should not happen that, okay, after detection they deny that no, it is not we who did it, but there should be, I mean, specific stamps which would show that yes, these are the parties, these are the TEs that were involved in the conferencing process. Okay. Now, all these security issues have to be built in no other place but the gatekeeper, okay, because all these protocols must reside in gatekeeper, and that is why in the gatekeeper routed protocol it becomes absolutely essential that all these have to be, I mean all this signaling have to go through the gatekeeper. Okay. Now, the RAS, even the RAS channel that is used from the gateway to the gatekeeper, okay, that is also not a secured channel, and that is why H.235 that has a gateway to check the authentication of the RAS message, because before the RAS message is passed on, okay, even the RAS message also has to be authenticated, because it is not through the secured channel that goes on. So, these are the security aspects which one should take into consideration. And I should also talk about certain, I mean, given all the good features of H.323, okay, the basic idea of H.323 should be to make it more and more popular, okay, and definitely its usage should be as much as that of the PSTN, eventually becoming more popular than PSTN, because PSTN happens to be the circuit switch network and should be much costlier, as we were mentioning in the earlier class. Now, the PSTN over the years, okay, has gone through several kind of enhancements. Okay. So, now you know that I mean, in the normal telephones, okay, you are getting, I mean, with exchange provided services, you are getting the caller identification, okay, you know who is calling you, okay. You can have a call transfer facility, you can have a call divert facility, okay, that if you are not on this telephone and if you are somewhere else, okay, you can just divert your call to that particular number. So, all these are some of the enhancement features that is already available in the PSTN, and the similar features should also be applicable or should also exist with the H.323 or in the VoIP domain. Now, H.323 per se did not have any of these extension features, okay, any of these enhancement features, okay, in what is called as the H.323 V1, H.323 V1. Okay. So, it is only some generic functional protocols and procedures, okay, between end to end, because you see that for the terminals there should be some end to end signaling that we are talking of, and this end to end signals functioning, okay, that should be defined, and in fact all these generic functionals as well as the subsequent enhancements or enhanced capabilities, instead of building them in the H.323, instead of incorporating in H.323 into it, what they did is to have another protocol called as H.450, which would reside on top of the H.323. So, there should be another protocol called as H.450, okay, which should sit on top of the H.323. So, this is on top of H.323, and or rather H.450 is a part of, okay, I mean, I should not say on top of H.323, but since it is all signaling enhancement, so I should say that H.450 should be on top of Q.931, because Q.931 is the signaling protocol that is there in the H.323. So, with the incorporation of H.450 on top of Q.931, we can now go in for enhanced versions of H.323, and in fact, we can go in for the version 2, version 3, version 4 and so on. Okay. Now, H.450 has got different sections into it. Okay. The H.450.1, that refers to the generic functional protocols and procedures. Then H.450.2, this refers to the call transfer. Then 450.3, that is call diversion, which essentially refers to the call forwarding. Then H.450.4, that refers to the call holding, call hold, and then H.450.5 that is call park and pick up, and then H.450.6 that is a message waiting indication, .7 that is call waiting, then actually this is supported in version 1, version 1 only supports this, version 2 onwards supports this, and I think this call park and pick up onwards, these are the things which are supported in version 3, and from the version 4 onwards we have some more enhancement capabilities. So, that is in 450.8 we have the name identification, 450.9 addresses the call completion, okay. 450.11 that refers to call intrusions, and so on. I mean, these are just some of the enhancements that I just referred to. You do not have to remember everything. Okay. The whole idea is that just to tell you that there are certain capabilities, there are a lot of enhancement capabilities which are there in H.450, which sits on top of Q.931 in order to have some enhanced facilities. Means whatever facilities are there in the PSTN's phones, okay, should also be existing with the VoIPs. Okay, that is what was thought of. Okay. Now, basically the inclusion of H.450, which was done at a later date, I mean not in the initial phase of the H.323, but it was added later on. A problem that was realized is that with this enhancement facilities, okay, is it that you are going to change all the terminal equipments, because the terminal equipments have been already there, okay, and users have spent money, okay, to buy those terminal equipments. Now, if you give the enhanced facilities and say that no, now you have to change your terminal equipments, okay, I mean everything cannot be done, or writing a new standard and then changing the terminal equipment, that is not something which is desirable or feasible always. So, at least some of these facilities, okay, I mean may not be things like the name identification and intrusion information, where specifically then the handset has to contain those capabilities. It must be having an LCD display, it must be having some particular form of messaging, those things will be there. But at least many of these things like the call transfer, call diversions, all these things should be possible with the Gatekeeper. So, there are many non H.450 enhancements, okay, which could be built into the Gatekeeper software. Okay. So, that is why, so that is what made the enhancements possible, okay, maybe in a bit of cheaper way. Okay. So, now, okay, the enhancements are definitely making the VoIP a very popular thing, but I think what needs to be done is that, is it as powerful as that of PSTN? Even if we include all these enhanced capabilities, okay, I mean is not that the VoIP as of present, okay, has got lot of limitations. It is mostly because, especially when I was talking to you about the third phase, that means to say that where the carrier grade telephony, okay, has to work with the VoIP, okay, there you would realize a major shortcoming, and the primary shortcoming that you will come across is with the number of lines that can be catered for. Now, today in exchanges, I mean whenever you are having the circuit switch exchange, there you can have a large number of lines, okay, maybe tens of thousands of lines which are catered for by the exchanges, but here it is only, I mean a few thousands or a fraction of few thousands which would be possible with the VoIP, I mean with H.323 as of present. Okay. Because one major shortcoming of H.323 is that if you look at the block diagram, okay, I think you would realize one major difficulty, that we are putting excessive stress on the gateway, because it is not, I mean I think yesterday we were having some discussions on this, that it is not the simple gateway which we are using for just the IP interface from one LAN to the other, okay, that if that only the protocol aspect is taken care. But in this case the gateway has to be an enhanced gateway, because the gateway also has to work with the interworking, gateway also has to facilitate the interworking with the PSTN. Okay. So, that is why lot of demands are put onto the gateway, and the gateway is quite a complicated. If you are realizing it by hardware, it would involve large amount of hardware. Okay. Also there will be considerable amount of software in the form of the implementation of the protocols which will be there. So, that, I mean doing everything in one box, okay, is indeed a problem that is going to be there with the gateways. So, there are some methodologies, there are some schemes which should take care of this, okay, and make the H.323, okay, as capabilities, okay, better. And in fact, this is what we will be seeing in the next class, that how those efforts were taking place. In fact, we will come first to the structure of the gateway. Okay, we have been talking about the gateway, but never seen the internal structure of it. We will see the structure of the gateway, and then we ourselves will realize the complication, and then there must be some form of an architectural change, okay, so that the gateways could be decentralized, okay, because at the moment there is too much of centralization with the gateways. So, any form of a decentralized gateway should help in the scalability. We will talk about that in the next lecture. Thank you.